Hi there, Mr. Sutton here. This is the IM3 Honors 4-2 Extra Practice number 1 solutions on completing the square. For this problem, I noticed that we have a squared term and a constant, so I can actually solve this one just by square rooting both sides. On the left side, that gives me just x minus 5/3. And on the right side, since I'm square rooting an equation, I've got a plus or minus root of 49 over 9. Now, I can actually square root these right away. That's just going to be 7 over 3, so plus or minus 7/3. And to keep going here, I have to add 5/3 over to the other side to get x by itself. So I have 5/3 plus or minus 7 over 3. But I'm not totally done because I can actually combine these and get two distinct answers. For one answer, we've got 5 plus 7 all over 3. And that's really 12 over 3, which is 4. For the other answer, we've got 5 minus 7 over 3. And that's just going to simplify to negative 2/3. So those are our two answers. For this one, we have no linear term, so that tells us that we can solve this one by isolating the x squared and square rooting both sides. To start that process, let's subtract 4 to get it over to the other side. And now I'm going to square root both sides. Now, when I do this, a few things are going to happen. So I'm going to have x equals a plus or minus because I'm square rooting an equation. And since I'm square rooting negative 4, I can pop an I out of that radical to get just positive 4 inside the radical. So I've got plus or minus I radical 4 then on the right side after I square root this equation. Now I can simplify a little further. Square root of 4 is 2. So then x equals plus or minus 2i. Trying to solve this equation, I notice that we have only this squared term and a bunch of constants. Since that's the case, that means I can try to solve this one by isolating the one squared term here and then square rooting both sides. To start that process of isolation, let me add 25 over to the other side. That'll give me 75 over there. And continuing the process, I need to divide both sides by 3 to really get this squared term all by itself. 75 divided by 3 gives me 25. Now I can square root both sides. So if I square root the left side, that just gives me x plus 2 with no square. On the right side, I'm going to have a 5. But now since I'm square rooting an equation, I have a positive and negative root that solve the equation. So that's really plus or minus 5 that I have to write over there. And to get x truly by itself, let me subtract 2, so I can write this as negative 2 plus or minus 5. At this point, it's time to actually combine these together since I can. I can't just leave it as a plus or minus, since I actually can combine negative 2 and 5. So negative 2 plus 5, that's going to give me positive 3, and then negative 2 minus 5 gives me negative 7. So those are my two solutions. For this problem, to solve for x, we can think about factoring it since it looks like an easy factoring situation, but then we'd be trying to find numbers that multiply to 1 and add up to negative 4, and there are no such numbers, at least none that are nice rational numbers. So let's go ahead and try to complete the square on this thing. I'll start by subtracting 1 over to the right side, and at this point I need to take half of my x term, so half of negative 4, and square that. So that's going to be negative 2 squared. So I'm adding negative 2 squared to each side of this equation. And now on the left side, since I've done that, I've completed the square. So I can factor the left side now into x minus 2 quantity squared. On the right side, this is negative 1 plus 4, which is 3. And since I've got a perfect square, I can now square root both sides. That leaves me with x minus 2 on the left side, and on the right side I've got plus or minus radical 3. Now to get x by itself, I'm just going to add 2 over there, so 2 plus or minus root 3 gives me my answer. For this problem, solving for x, it turns out you actually could factor this thing, and it will end up working out. But let's go ahead and just use completing the square just to get practice on this one. So if you want to do that, we have to subtract 1, clear out the constant to start us off here. And then, since I have a number that's not 1 next to the x squared, I also have to divide by that a value on everything. So that's going to give me, dividing everything by 2, I'm going to get x squared minus 3 halves x equals negative 1/2. Now I'm going to take half of my b value, so half of negative 3 halves. To find that, I have to multiply that by 1/2, so that's negative 3/4. So I'm going to take negative 3/4, I'm going to square that and add it to both sides. So adding negative 3/4 squared to each side of the equation. And now what I've done is to complete the left side here. I've completed the square on the left side. So I can actually factor the left side into x minus 3/4 whole thing squared. And on the right side, I'm just going to simplify this a little bit. So this is negative 1/2 plus, squaring this gives me 9/16. Before I go ahead and square root both sides, I'm going to clean up the right side a little bit so that I just have a single number. So let me start by getting a common denominator. I can turn negative 1/2 into, let's see, how many 16ths would that be? That would be 8/16, so negative 8/16. And then negative 8/16 plus 9/16 is 1/16. All right, I've got a perfect square on one side, just a single number on the other. Let's go ahead and square root both sides. So I'll have x minus 3/4 on the left, and on the right, the square root of 1/16 is 1/4, so plus or minus 1/4 over on the right side. And now to get x by itself, let me add 3/4, so I'll have 3/4 plus or minus 1/4. Since I can actually combine 3/4 and 1/4, I'm going to go ahead and do that. So first I've got 3/4 plus 1/4, which is 4/4. 3/4 minus 1/4 is 2/4. And I can go a little bit further and reduce those fractions. 4/4 is really just 1, and 2/4 is 1/2. So those are our final simplified answers.